Hello and welcome to this eSchool Media webcast. My name's Andrew Barber. I'm a senior contributing editor here at eSchool Media, and I'll be acting as the moderator for today's presentation, which is sponsored by MapleSoft. And over the next hour or so, we're gonna take a look at some of the tremendous advances that have been made in automated grading in recent years, and explore how today's systems are, in many ways, worlds away from grading systems that you may have used in the past. And in particular, we're going to hear how the University of Birmingham in Britain is using MapleSoft's automated testing and assessment tool, which is known as MapleTA, to encourage active learning and independent study among its students. Before I introduce our speakers today, though, I'm just going to take a couple of minutes to highlight a couple of things about the console that we're using today. First, we are recording this event. In a couple of days, we'll send out an email to everyone who is in the audience today that contains a link to the recorded event, and you'll also be able to download a PDF of the presentation from that same email. And second, please ask questions. Don't feel as if you have to wait until the end. At any point during this presentation, if you have a question, just type it into the Q&A box on your console and hit the submit button. And I think we're probably going to have about 10 to 15 minutes or so at the end when our speakers can answer your questions. We also have a chat function. If you look down at the bottom of your screen, you'll see a blue group chat icon down there. Just click on that and use chat to talk among yourselves, share experiences with other educators, or contact me or the eSchool Media team if you're having technical problems or anything like that. But I do have one favor to ask of you. Please don't use the chat function to ask our panelists questions. They're simply not going to have time to monitor the chats while they do their presentation. So again, if you have a question for them, use the Q&A panel instead. And one final note is if the slides do not advance for you for some reason, one problem that may be is that you do need to download the Flash to make it happen. So if you are experiencing trouble with the console, make sure you have downloaded Flash, and hopefully that will resolve it. With that out of the way, let me tell you about today's speakers. Johnny Zivku is the product manager for MapleSoft's online education product. He's been with MapleSoft since 2009, working in a variety of roles, including with the technical support team, the quality assurance team, and the project management team. And Johnny earned his BMath from the University of Waterloo. And our other speaker today is Jonathan Watkins. John is the MapleTA development manager at the University of Birmingham and also serves as a MapleTA specialist for MapleSoft. John first worked with MapleTA at Birmingham when he trained a team of staff and interns to write STEM-based questions for the College of Engineering and Physical Sciences. And he recently completed a PhD in theoretical physics at Birmingham. Welcome, Johnny and John. I mean, it's a real pleasure to have you here today. Johnny, why don't you get us started?
Yeah, thank you. So, as you can see, the title of this webinar is, Are You Failing Your Students Without Realizing It? And if you're grading math tests and assignments exclusively by hand, your students may be missing out. That title itself is rather provocative. So let me explain exactly what I mean by the specific title. So typically, in the past, using an automated grading system for math-based assignments could actually be detrimental for your students. So for example, multiple choice questions just can't tell you if the students understand how to solve the problem, or if they understand enough to eliminate the obviously incorrect answers. Or each test could have, of course, they could just pick the right one at random. But automated testing and assessment software has come a long way, and I'd like to argue that we have reached the point where if you're actually not taking advantage of a good automated testing system in your STEM course as part of your grading mix, you're actually doing your students a disservice. And here's why exactly. So, your students learn by doing, especially in the math courses and the science and engineers. They typically will practice and do things multiple times to make sure they understand the topics that they're trying to learn. And one of the most effective ways to get them to do these things is to give them assignments. I remember myself in undergrad, I would get a weekly assignment in each course. And that's how we learn. Now, these weekly assignments weren't worth very much at all of my total grade, but that's how we took the theory we learned in class and learned exactly how to apply that theory. So this, again, motivated me to do the work, and I got feedback from the teacher as to what I got right and what I got wrong. And I guess the question then would be, would you give your students more assignments if you weren't limited by your time as a teacher or the time of your TAs, as they have to do the marking for you typically? Now, another thing, though, is without an automated system, practice questions are limited to those found in the textbook or on assignments themselves. So students who need more practice typically can't easily get it. But an automated system can generate typically unlimited practice questions and give the students instant feedback right away. As well, one issue that we've seen is the topic of human graders, and typically we have to rely on them. We have to rely on the human graders to actually look at the student's paper and grade it by hand and actually provide feedback by writing it on the paper itself. Sometimes this might take a couple of days. It might take a couple of weeks. In the meantime, though, you don't stop the course until you have finished grading everything. You keep marching on. You perhaps have given them more assignments. Maybe they've even started to study for a midterm or a final of some sort. They would probably feel a lot more confident in their understanding and be able to take corrective action on the things they got wrong in the first place if they got feedback much quicker. As well, when you start, when you're using paper assignments, it usually takes far too much effort to create and manage more than one version of the assignment. I definitely have seen in my experience multiple versions of a midterm or a final, but for the weekly assignments, definitely it's usually typically just one version that floats around. So students, being somewhat short-term goal-oriented, they usually copy answers. They usually work in groups. They usually work on an answer apiece, and then they share them with each other. On the other hand, though, if you could easily give every student a different version of the assignment, students have to help each other learn instead of just sharing the answers to their problems. And also, when you're using this idea of manual grading with a teacher, whether you're doing it by yourself as the professor of the class, or you have maybe some grad students or maybe some third or fourth year students that you've hired as TAs, it simply takes up a lot of time. What else could you or your TAs be doing with that time to help your students or to meet your other responsibilities? But I think you get the idea. But of course, you'll only get the benefits of an automated testing system in your math-based courses if it can actually handle the material properly. And that's difficult. So I want to take a few minutes to consider what it would mean to have a good, and I'm doing that in air quotes right now, automatic testing system for the STEM courses. Now, if you're attending this webinar and you're not too sure what STEM means, I should probably explain myself. STEM is definitely a more popular acronym in North America, but STEM stands for science, technology, engineering, or mathematics. So it's basically any course involving math itself. So first of all, it must support this idea of FreeResponse questions. That is, there must be a free-form response area, similar to how students simply get a blank space on their paper-based quizzes. This way, students actually have to solve the problem with no hints as to what the answer, might look like itself. And now that we've got a response, one of the biggest stumbling blocks comes from the issue of mathematical equivalence. Now, there is usually more than one way to write down the same expression, and much of the time you could consider all variations to be correct. Now, our ideal system would need to be able to recognize automatically equivalent math expressions, just like a human grader would. So rather than yourself having to type in, 1 minus sine squared x is equal to cosine squared x, the system itself should do that for you. You yourself should have to think up all the different possibilities or equivalencies that you have to provide into a system. It should handle it automatically. Now, sometimes the issue is not that there are different forms of the correct answer, but maybe the issue is that there is more than one correct answer. So, for example, if you're going to ask a math question where you want them to give you an example of a function that's increasing on a specific interval, or you want them to give you an example of invertible matrix, right? In this case, there are infinitely many correct answers, and a human grader would know how to apply the proper test to check their answer is correct, and our ideal system as well should be able to do that as too. So exactly what else then? Well, we want our ideal system to be really good at generating algorithmic questions, and we like for it to be flexible, truthfully, so it should limit itself not just to, fill in the random integer templates, but allow us to ask for things like matrices with certain properties, or prime numbers, or polynomials with specific degrees. You should have the flexibility to create exactly what you're looking for from a mathematical perspective. As well, when it comes to the whole idea of visualizations, which is really important in courses involving mathematics, it should be able to handle all sorts of different plotting options. So things like plotting 2D, 3D, polar plots, statistical plots, animations, and so forth. We should really be able to generate them algorithmically as well. It's not just having a static image on the screen, but actually having an algorithmic type of plot that they can actually interact with, they can play with. They can zoom out, they can zoom in, they can rotate at their own leisure. The system should be able to support that as well. And while we're at this whole idea of visualizations, let's also talk about this idea of extensive question types. So free response is obviously extremely useful, as I mentioned before, but let's also add in the ability to sketch graphs and plots, and questions that can handle units and margins of errors and have different tolerances and precision methods, and a bunch of other stuff, including the standard, what you'd expect, multiple choice, fill in the blank, true, false, because these are all very useful at times as well. Now, of course, this all sounds great, but I guess the question is it real? And can a system really do all of these things? Well, of course, that the answer is yes, so I wouldn't be here talking to you today. This is real. This is MapleTA, the powerful online testing and assessment system for MapleSoft, which was designed especially for courses involving mathematics. In fact, MapleTA does all the things I just talked about. MapleTA is built in the Maple mathematical engine, which gives it a lot of mathematical power to draw on. That's why it can, of course, handle this idea of the free response math question. This is also, of course, why MapleTA can handle the idea of mathematical equivalency. It will automatically look at the student's response and make sure it's mathematically equivalent to what you, the teacher, assumes to be a correct answer. As well, it can deal with open-ended questions with infinitely many correct answers. So it'll actually be able to check the properties of the response to make sure it satisfies them from a mathematical perspective. And MapleTA allows you to have this idea of flexible question generation, not just picking a random integer between 2 and 10, for example, but actually picking functions and matrices and plots that satisfy math commands. You can actually build that into the questions when you create them. And of course, visualization is a big part of MapleSoft's vision in all of its products, and MapleTA doesn't suffer from that either as well. So MapleTA allows you to deploy these really rich and animated and visually interactive options and images right inside of the actual student experience itself. And MapleTA itself has a large number of question types for both the non-technical and technical content types that you want to deploy to your students. Now, there's obviously a few more things I'd like you to know about MapleTA that I can't cover everything, and you can find more information on our website, but here are some highlights that I want to talk about. So first is technology integration. So MapleTA itself, we integrate with your technology. So if your school is using some type of learning management system or a VLE, a virtual learning environment, you can integrate Maple TA into your existing systems to actually provide this more seamless integration and experience for your students. Maple TA will actually be a part of their existing ecosystem that the students are already used to. So for example, we definitely support Blackboard and Brightspace by Desire to Learn and Canvas and Moodle and all sorts of other solutions that are out there as well. Now, when it comes to students, they typically have a lot of different devices. Some of them have laptops, some of them have smartphones or tablets or something in between these days. Maple TA works on any web-enabled device. We have a responsive design that will make it a good experience no matter what type of system or platform they're coming from when they go to use Maple TA itself. And another important aspect about Maple TA is that it puts you in control of your testing content. So you can choose from pre-built content that's already out there, but you're not locked into that content. You can always modify the content you get from our pre-built sources and adjust them to better suit your specific needs. Or you can create your own. Maple TA has the most comprehensive, easiest to use authoring tools available for the STEM-based content that you want to create and deploy to your students itself. Now, to make this all more concrete, let me tell you about the experiences of a few schools that are using Maple TA. So first I want to talk about U of G. This is University of Guelph, a school that MapleSoft has been in partnership for several years. And they found that the use of Maple TA at U of G reduced the dropout rates by more than 10%. And here's a quote that we'd like to talk about, is that the lower dropout rate and the quality of the students who dropped out indicate that students who used the Maple TA tests and assignments had a better understanding and grasp of the subject than the other students themselves. And I also want to talk about going to Europe now, the University of Turin and the town of Turin. So they do this really cool thing with Maple TA that they've actually integrated right inside of their Moodle environment. And they use it for teacher training. And they use it to increase the confidence among high school students along with homework completion, knowledge, and class participation. As well, keeping our theme of Europe, the Amsterdam University of Applied Sciences, they found that while using Maple TA, student pass rates went up approximately 20% within their first year alone. And at first the low pass rates were a concern. Online learning and digital testing was a key pillar to the new approach, and they did a lot of their online assignments and homework and tests using Maple TA. And they used these results to develop a customized learning path then for each teacher. Student. And one other school then as well, Collegial Munoz, pass rates among students increased significantly. They found that the more time that they had now, they actually use for students on a one-on-one basis. So instead of using the lecture times for here's the content, let's do some tests and everything, they had more time now available for students who were struggling. They could actually meet with them. Teachers and TAs weren't spent using their time on marking and doing things by hand. They could actually now talk to the students instead during tutorials and those special times that they had outside of lectures. As well, the Chalmers University of Technology. So most of their summer math program, student administration, testing, and grading was accomplished by a staff of 2. So they have the summer math program that students can take to improve their math skills, and they found that new students, especially, they were struggling with math. So they used Maple TA within this math program to introduce math to students before they even came to school. Here's a quote that I just want to read as well. We wanted a way to bring students back up to speed with their math knowledge before they started attending university math courses. MapleSoft's online system for testing and assessment seemed like the perfect solution. They also really liked that the Maple TA system was backed by Maple, and Maple is used in many of the academic programs at Chalmers, so Maple TA just seemed like a very obvious next logical step. Now, in that same approach, they found that there was greater engagement in this joint summer preparatory program that was capable of handling more students more easily. And one more to talk about here is the University of Waterloo. So they have been using Maple TA for almost a decade now, and they found that after they moved to Maple TA, they found that they could actually save approximately $100K per year on their grading budget because the number of TAs they had to employ before who were simply just grad students or third or fourth year students, they were able to accomplish most of that now through Maple TA's automatic grading system itself. So I guess I just want to say, are you failing your students without realizing it? So given what I talked about, a lot of the advancements in automated testing and assessment software for math-based courses, maybe it's time to rethink your approach to how you deliver tests and assignments and practice homework and exams to your students. So at this time, I do want to just pass the presentation over to John Watkins from the University of Birmingham.
All right, thanks very much, Johnny. So it's really nice to see some of those exciting things from Maple TA there and other great success stories from other universities. So I've worked with many of these universities throughout my working with MapleSoft, and everyone's doing really great, exciting things in the area of e-learning. And so I'm going to talk to you a little bit about some of the exciting things we're doing at Birmingham and where we have been and where we're going and how we accomplish that. So just a little bit of background. The University of Birmingham is one of the largest universities in the UK. We have around 30,000 students. And so as you can imagine, grading assignments from them is a big task and very costly. So just as you can see on the slide, you see a little picture of the university there. It's the Red Brick University, so it's a very prestigious university. It's based in the center of the country, so you can see that on the little map on the left. And just for a little bit of fun, this is a photo by a student who became a pilot and maybe rose to higher things and took a photo of the university as they were passing over. So that's a little bit of background. So I think we're in many ways, a very typical university. And like all the universities I speak to, we all have a very similar problem, which is we have increasing student numbers and we want to give a good quality of teaching. So let's look at the computing world and see what we can do and how we can build resources that last and can be useful broadly across the spectrum of all the subjects we're trying to teach. So as we see it, the problem is that creating content can be time consuming. If any of you have written an exam or written problem sheets for your students or tried to think up questions, that takes a lot of time. And as you know, good quality content takes a long time to make. So we also know from experiences using the web and things like that, web technology can be very quickly become obsolete. And you really want somebody to sort of guide you and help you and look after that for you. We know that resources can take time to maintain. And so again, we want systems that are going to be around for a long time and systems that are easy to maintain. And a big problem we see in technology is that a lot of people tend to use digital just because we can. And I see these things as I made a PDF, put it online, and now I've got a digital course. And that really is not digital enhancement. And then finally here, we have the other problem, which is so many teaching tools. Which ones do we choose? How do we give our students a good path through the content? So we're going to take these and then make targets out of them. And so we're going to choose the best teaching tools to teach the concept and let the concept lead what tools we use. We're going to use digital to enhance. So where digital is a new thing we can use for teaching, we're going to use that to its fullest potential to really get these ideas and these learning concepts across. We want to make our content small and shareable. And what we mean by that is if we can make our content small and atomic, then we can use it in lots of different places and build larger things out of it. That gives us a lot of reuse. And that comes back to the hands-off maintenance point. So how can we create resources that we can easily maintain and not have a lot of maintenance costs going forwards? And then as always is important to universities, we need to use and integrate with the existing platforms that are there. And so for University of Birmingham, the existing platform was Canvas, and now we're adding on Maple TA. So that's kind of what we're up against, and we're up against it because we're a large institution trying to solve a large institution problem. So what I'm going to do now is I'm going to quickly go through some of the platforms that we use, how they integrate, and how we use them to solve this problem. So let's start with Canvas. At the University of Birmingham, we use Canvas. We find it to be a nice virtual learning environment, and it's a great place, central location for all our teaching content. All staff are trained on how to build content in Canvas, and there's a support team at the university that do that. And so they can add lecture notes, course content, make simple quizzes, things like this. So we have to start from Canvas as our launching point. All students have a single password and a single username at the university, and everything goes in through Canvas. So we must, whatever tools we use, we must integrate with Canvas. Canvas also enables us to track student activity. And so, as you all know, that the learning analytics is a great big growth area. And so having a tool that can do that is really important. I've already just mentioned the single sign-on, but this is a very important point for the students at university, particularly early on in their first weeks of term. Remembering one username and password is enough hassle for them. And then Canvas supports things like rich HTML content, where you could use it in a sort of formative mode to explore something and maybe embed YouTube videos and things like this. And then it has a really nice API to enhance functionality. So that's the baseline of where we are. We're starting from Canvas. But Canvas doesn't do everything. So our ethos at the university has been to say start from a solid base, and when there is a deficiency or we want to do an enhancement, we're plugging in third-party providers to do that. So here's a quick example of how we might plug Maple TA into Canvas. So we use Maple TA for a number of reasons at the university. One of the first reasons was because we want to have more control of mathematics. So be able to generate questions where we have more control of mathematics, more control of the grading. And really, Canvas, while it's a great launching point, is not trying to be a STEM-focused tool. So what we've done is we've plugged in Maple TA to our system, and that gives us this mathematical power through Maple TA, through the Maple engine. So what you can see on the screen is an example of a Canvas course. This is a course called the Maple TA Study Zone, and it's a course that is open to all students at the University of Birmingham who are logged into Canvas. It is made up of content that has been built over a couple of years. That might be past exam papers, it might be past problem sheet questions. It is content that's all been built up around these modules and put in this course for students to access anytime they want. So by logging into Canvas, logging into this course, they can launch into Maple TA through one of these links, and it will take them to some really focused content around their subjects. This is really nice because it gives students the 24/7 practice when they need it. It's not judgmental. It's not sitting there and making them feel guilty for not knowing anything. It really is giving them the chance to have that real drill and practice they need to get good at mathematical subjects. So that's the Maple TA Study Zone. So let's have a quick look at how a little bit more of a deep dive into that Canvas course. So if we go into one of those modules, what we see is something like this. This is a very simple page. It actually is the course syllabus for this particular course. And all you can see there is a couple of hyperlinks, where we've just hyperlinked a couple of topics with trigonometry, various pieces. And each of those is associated with a Maple TA assignment the student can then click on and take. So while you can design nice adaptive learning things, we've taken a very simple approach and said the students struggle on things, they struggle on topics, they know the words, the things they're struggling on, because they're the words the lecturer is using in the course. And when they're stuck, they can go into this, they can click on this any time of the day or night and get practice when they need it. So, as Johnny said earlier, in order to get this real good mathematical practice, we need this tool to understand how the students input things. So just a quick example here of the equation editor in Maple. Again, as Johnny said, it's a really lovely tool because it allows you to put FreeResponse in there. Now, FreeResponse is really nice because it doesn't lead you down a path of telling you what answer the answer form might look like, which is another way of giving students hints. And if you really want to test their raw mathematical knowledge and give them that blank piece of paper and almost the fear of going, I've got to do this on my own, then this equation editor really supports that. It has a number of other features which I really like as well, and I've observed in a lot of the classes that we run. So you will all appreciate that you have students that have used calculators at school, they've used Excel, they've probably been learning programming languages, but after a summer of having fun before they come to university, they've forgotten all the syntax that you might use in Excel, or how to use a calculator, and all these things. So when they arrive at the university day one, they want something that's friendly, something that's easy to use, something that helps them type the mathematics into the system to grade their answers. And as you can see with this equation editor, as you type, it formats it for you, and it looks like the mathematics you'd write on a piece of paper, which is really nice. Now, not all students might know some syntax, so if they don't know syntax, as you can see there is a palette where they can click, and it will embed a template of that particular object, and they can modify it and change it. So it's a really nice hybrid editor that really brings students in right from day one and supports them to be really advanced Maple TA users. So now I'm just going to zoom through some of the rest of the features in TA as far as input modes. And what you'll see is a lot of really graphical and rich ways of entry. So this is really using digital well. You've got little apps that you can manipulate and modify and watch the students' activity and grade how they've responded with this visual environment, something you find very hard to do on a piece of paper. You've got tools for STEM-based subjects that you can resolve forces, and other really interactive content around which really brings mathematical concepts to life. This can be used in both a formative and summative mode, so students can really get a rich experience of learning using this tool. Okay, so as I said earlier, one of our targets at the university is to reuse content. And we really think this is important because if we build content, test it, we want to reuse it at as many places as possible. So that's our target. So we started off with the year one and two mathematics for physicists courses as our baseline content that we were going to build. They're very mathematical courses, but they kind of sit at the center of a lot of STEM subjects. So when we build content for these courses, we can then reuse that content all over the place. But before we start reusing content, we actually put them through a fairly rigorous building and development and testing program in order to build confidence that we have good content. Because as all of you will know, if you've written an exam paper, and it's very, very rare that I have sat in an exam without seeing at least one or two mistakes on that exam paper. And so with these systems, we are no different. And so we really want to build, test, and release content in a structured fashion. So we do destructive testing on it. And to do that, we actually use interns. And I'll talk about that a little bit later. But yes, we do destructive testing on all the content. And we really take it through this development, testing, and release process before we put it into a central place that all lecturers and students can access. So what do we do once we have this wonderful set of content? Well, we start reusing it. So we look for overlaps in other subjects. So we take it from the math courses in physics, and then we break it out into the physics courses. And we use it in things like quantum mechanics, and we have things for grading Dirac notation in quantum mechanics. We use it for relativity, where tensors and matrices are very important. We then take that content from the year one and two maths for physicists and move that into the engineering subjects, which again, there's a lot of overlap with. Surprisingly, then we take it from physics and move back into mathematics, but again, there's lots of overlap. So as you can see already, we're starting to reuse this content over and over again, building up confidence in it and really getting a lot more value out of that content for us. We can move slightly further away from the physics, maybe into the chemistry labs where things like error is important, and all that content from maybe the earlier year one content in physics, we then start reusing in chemistry. Another big growth area we're seeing at the University of Birmingham and many, many universities using Maple TA is bridging content. So you'll all have students that at high school, at pre-university, have to get up to some standard. Those standards are often very different across different territories, different countries, and really it's very hard to know what levels a student's at based on the grade they have on a piece of paper. And also on top of that, we have the problem that students forget everything. So a really big growth area is building bridging content, and we use our year one and two maths and physics course content to build that as well. We then take the content and move into areas like economics, with some lovely growth we're doing around things like statistics, and even now we have plans to move it into medicine this year. So as you can see, from a very sort of humble start in physics, we've then taken it and really reused it across the whole College of Engineering and Physical Sciences at the university. So let's have a very quick look about what one of these pieces of content might look like. So actually, interestingly, this example is actually not a piece of content that's written at the university. It's a piece of content that we got for free out of the Maple TA cloud. The Maple TA cloud is a great resource for free content that's been built by other universities, being built by MapleSoft, that's freely available in the cloud. You can just go in there, browse. You can pull out single questions, full course assignments, or full course modules. And actually, this is a question we pulled out of the cloud. And so what you can see on this screen, this assignment has actually been set up as what's called a study session. And it really is how it sounds. This is a student who wants to study a particular thing. He's going to sit down, he or she are going to sit down for some amount of time and really try to get their head around some concept. So this particular question is about radians, and what the student would do is have a go answering the question. If they want a hint, there's a hint button at the bottom. If they want to see the solution, they can press to see the solution. If they just want to give up, if they want to grade the question, they can press grade and see how they've done. If they didn't do particularly well, or they thought that maybe I did well, but maybe that was lucky, they can press try another, and the system will generate another question of a similar type for them. So all that real power of Maple really comes to play here, where the system can actually generate mathematically rigorous questions that the student can have lots of practice on. So from sort of a very humble thing of making one question, you can get many, many questions that sort of blossom out of that. And that's a really nice experience for the student to build confidence and really keep them motivated to keep coming back and keep learning in these systems. So as I've already mentioned earlier, once we've built this content using the Maple Cloud and other sharing facilities within Maple TA, this content is now freely available to all Birmingham staff and students. So that means they can Birmingham staff can build content really quickly out of existing content, and students can access the massive bank of content that we have and get practice anytime they want. And that just really improves and increases the building time for resources at our university. So, okay, so what I've talked about so far is Maple TA and building assignments with questions in. But can we go further on this? Where can we go to next that we can actually build on this sort of nice quizzing and testing engine? And what else can it provide us? So an obvious next step is learning material. So if we have learning material, can we not just take our students through in a testing mode, but can we take them through in a teaching mode, where we can actually use a STEM-based system with a mathematical engine behind the scenes to really improve learning at the university? So what are some of our requirements for that? So we want things to be easy to manage. So we want a system where we can keep our lessons in, share them around, building blocks, that sort of thing, and that's one of our big requirements. As we know, lesson content takes a long time to make, so that's a big deal. We want end-to-end analytics, just like I mentioned earlier, when we have the Canvas, which has a nice analytics engine. We want the same analytics in Maple TA and in any product, so we can actually see how students move through content. We also, and so once we have built these contents, they're easy then to share. And as we all know, the web is really developing very fast, and it's becoming a really rich place of content. And if you just do a quick search on STEM content on the web, what you'll find is lots of nice JavaScript and HTML5 apps out there that people have built. Now, these are really nice apps, and can we take some of these apps, can we embed them in our learning systems and actually see the students interacting with these apps and really see how their learning experience is improving as a result of them having access to this? So fortunately, and maybe I've been leading to this, fortunately MapleSoft have come to the rescue here again, and they have come to the rescue with one of their new products called Mobius. So Mobius takes the power of Maple TA and adds lesson content and interactive courseware material on top of it. So it really is a model where we have a solid Maple engine at the center, we build solid testing and assessment on top of that, and then we extend that out into courseware material. So let me show you a quick example of what that might look like. And so what you see in the picture here is a very quick example of matrix inverses. Now, originally, this was a piece of paper, a PDF, and the lecturer who wrote this originally felt that the piece of mathematics, the mathematical description of this was completely adequate, and that would work really nicely for the students. Now, the lecturer felt that because on paper they hadn't got any more options. So on paper they had what they had no interactivity, so they couldn't show some of the things you can show. But with a system like Mobius, what we're able to do is take those mathematical contents, really bring them to life, and allow them to be interactive. So we can not only calculate the matrix inverse, we can also visualize the matrix inverse and see if I'm actually making it, calculate it correctly or incorrectly. And that really is the power of using digital to enhance. It's not just a replacement for your piece of paper. We really can enhance with digital technology. Okay, so finally, let me come on to how we do this, because as you can probably tell, we've had there's a lot of content we've built at the university, and well, I would love to claim that I've done it all myself. I haven't anywhere near done it all myself. So the way we do it at the university is every summer we have a very strong interns program. Each year, for the past 3 years, we've had around 12 interns at the university, and they're interns that we hire from the college to work for 8 weeks over the summer. We teach them how to build questions in MapleTA and Mobius and lesson content. We teach them how to grade questions. We teach them how to think like a lecturer, how you might teach them about pedagogy and didactics. We teach them about how to code JavaScript. And we really get them thinking like lecturers, but in this new digital space. We also teach them how to juggle, which is just a bit of fun, but it really does build a really great team around this. And as you can, and the pictures you can see on the screen now are our interns from our recent summer 2017 program. If you're interested in what we do, if you look at the URL below and go to that, you'll see you'll see a blog that the interns write every year. I will warn you, they just write the blog themselves. We don't edit it. It's really just their experience of using the product. It's very, very real. There is a post every year, 2016, 2015, and so you can look back through time and see how we've done it. Now, this is a really wonderful project. It's very energizing. They work with, so the way it works, the way we build it is we take the groups of interns, we pair them up with lecturers at the university. They work together to build content. The lecturer will test the content, the students will test the content, and it really is a partnership about building these questions together. Once that's happy, the lecturer takes them and then they deliver them in their courses throughout the rest of the year. So I think I've said enough really about how we do this. By all means, if you want to catch us and see what we're doing, go to that URL, and we are all over Twitter as well. But for now, I'm just going to thank you for listening to both myself and Johnny, and pass you back over to Andrew for some questions.
All right. Well, thank you so much, John, and thank you, Johnny, too, for a really fascinating presentation. We do have still just a little over 15 minutes left. So if you do have a question for John or Johnny, by all means, just type it into that panel, the Q&A panel, and hit the submit button, and we'll do our best to reach all of them. But we do have some already in. And I'm going to, John, I'm going to turn to you first with a question that came in from Susan. During your presentation, you talked about how the mathematics engine has a dual role in some other areas like physics or chemistry. And the question from Susan is, can the software work for non-mathematics based sciences or social sciences in which the responses may come in words or phrases or sentences? Is that a possibility?
Yeah, absolutely. Yeah. So the engine in MapleTA can be used for all sorts of things, and I've seen some really lovely examples of how people do things. One of my favorite ones recently I saw was from a university when I was in Turin, actually, at a recent conference, and they were using MapleTA to teach English to their students before they went into mathematics. So this is a really great use case for it, and so MapleTA has built into it question types that you can do fill in the blank questions, where we can spot where they can you can put multiple different answers in, and it can also do longer form sort of free response areas as sentences where you can highlight words and things like that. So yeah, some really nice use cases. And so one of the other things you see around that is that a lot of people will write work solutions and explanations as additional information for a lecturer to review. So yeah, sentences and words are really a big part of MapleTA as well. Okay, great. All right. Well, thank you for clarifying that.
Johnny, I'm going to come over to you now for a question from Kelly, who wants to know whether, I mean, during the presentation, John showed how they're building off Canvas. The question from Kelly is, can this be integrated for Google Classroom or OneNote?
Yeah, so at this time we integrate into other softwares using two different methods. The first method is through Learning Tools Interoperability, so LTI. So a lot of the learning management systems and content management systems and VLE support LTI as a consumer, whereas MapleTA and Mobius is an LTI provider. So we do integrate with any other LTI consumer. As well, we do have what's called the MapleTA API or the Mobius API, and this allows you to do a custom integration into your software who do not support LTI. So at this time, I don't believe that Google Classroom or OneNote support LTI as consumers, but using the API, it could be possible if you put the work in to integrate MapleTA or Mobius into those solutions. And of course, the typical reasons for integrating into other solutions is for single sign-on or even for launching assignments or lessons from other areas. So to answer the question, is it possible for Google Classroom or OneNote? If they support LTI as consumers or they can integrate with their API, then the answer would, of course, be yes. I, at this time, don't know if they do have those things off the top of my head, but it could be looked into if wanted.
Okay, all right. Well, you know, there was a second question that came in from Kelly, and John, I'm going to come over to you for that one, which is, you know, during the presentation you focused on obviously what you were doing at the University of Birmingham, and the second part of Kelly's question is talking about the use of the product in middle schools and specifically a middle school math classroom. Do you have experience in terms of and how it differs from what you've done at Birmingham of how MapleTA is working in grade school?
Yeah, so I mean, it's definitely an interesting area of development. So just for a little bit of background, I actually use MapleTA for my children to teach them mathematics, which is always a bit of fun. It's a good excuse to practice writing some questions. So yes, I do know it can be used for the middle school age. But no, as a sort of more formal answer, yes, we do actually work with schools in different territories, so places like Denmark, to actually use MapleTA in schools. And it's quite a nice use case of it. So obviously when you go to middle schools, you tend to use more visual things. And tend to really focus more about learning design because, as you know, at university, you tend to focus more on the mathematics than less on the learning design. But yeah, so it's a really nice tool for using in middle school. And yeah, it's something you can do. So by all means, have a go.
All right, terrific. Johnny, I'm going to come back to you now with the next question, which comes in from Bonita. And there was some reference made to medical questions. Can you just clarify when will MapleSoft have the medical questions entered, and will it be by the summer of 2018?
Yeah, I personally don't remember. I don't remember mentioning these medical questions myself. I don't know, okay. John, did you mention that?
No, it was me, yeah. It was me that mentioned it, yeah.
Oh, sorry, so, I got it wrong.
No, that's no problem. It's fine, yeah. John and Johnny, it can be confusing. But yeah, no worries. Yeah, so a lot of medicine is, I've seen a few different nice use cases of medicine. So, and it's probably worth browsing the Maple Cloud to see what's been published there. But the ones I've seen that I really like are statistics-based questions. So things like t-tests that I've seen. And so obviously Maple has the full capability of writing all statistics tests, which are very important for medicine. But I've also seen some fun questions about diagnosis where people have provided, said things like using text-based answers, really saying, here's a set of symptoms, and they've actually used the Maple engine to generate multiple choice questions, which have very enticing possible diagnoses. And so I've really seen that as a really nice use case. And finally, the other medical things I've seen are the use of the clippable image question type for identifying like parts of anatomy. So yeah, just like any subject, when you have a really powerful tool like Maple, you can use it to build lots of fun things. And it's not just about mathematics content. It's about interactive content and content that requires you to make decisions on what students are doing. So yeah, so that's what I've seen so far. As I say, look in the cloud for what's there. It's the best source of information that we have for what people are pushing out there.
Perfect. All right. Well, thank you. And I'm sorry I directed that to the wrong person. So, but Johnny, I'm going to come back to you. A question from Shivapa, who says that at the moment he's using WebAssign to teach his calculus course. He's interested in how he can use MapleSoft, and he's also interested in the kind of the pricing and the cost structure that MapleSoft uses.
Yeah. So definitely when it comes to calculus and linear algebra, those are our two biggest courses that people adopt and use MapleTA for. Typically, people use MapleTA for those courses for their weekly assignments or for practice homework or the midterms and finals. Now, Calculus 1 and 2 are big parts of MapleTA, so we have a lot of pre-made content for those disciplines. We have individual questions you can browse through and use, or the whole actual course packages you can download and install and kind of pick and choose what parts of the course you want to use or not. Now, in terms of pricing, pricing for MapleTA is done on a per student per year basis. So what I mean is you pay per student, and that student can do as many courses and assignments and questions they want in MapleTA in a given 12-month period of time. The price itself is dependent on the volume of students that you anticipate using MapleTA in a given 12-month period. So to give a proper quote, we will recommend that you contact MapleSoft to find out exactly how much it would be per student for your school itself.
Okay. All right. Thank you. For this next question, John, I'm going to stick with you for this one, and then afterwards, John, maybe you would also weigh in with your 2 cents on this one. And the question really is how difficult is it to author questions in MapleTA? Johnny?
Yeah, I'll go first. So MapleTA, we don't make it difficult for you to author questions. We have a point-and-click editor that helps you create the content, whether you want to embed videos from other sources or images, or the questions themselves don't require any knowledge of programming. It's all done very intuitively through the authoring interface. In terms of making a question algorithmic, again, you don't have to be an expert in programming. We do have an editor that helps you build your algorithms by pointing and clicking with your mouse and typing some words with your keyboard. So we have found that the authoring experience, especially in our most recent versions of MapleTA, which we've worked on to improve the authoring experience, it's quite easy and quite fluid. We have a lot of positive feedback from a lot of people who don't have experience with programming or things like HTML or JavaScript. They're just pointing and clicking with our interface. So I think it's quite easy to create content in MapleTA. Of course, perhaps having John talk on that would be helpful as well to give his thoughts on how he learned and how he's trained other people about it as well.
Yeah, thanks, Johnny. So so just a little bit of background. So before we started using MapleTA, we used a different piece of software, a lot of the techniques you learn about computer algebra systems are transferable. So that's the first thing to say, and it is a different skill to writing an exam. Now, as Johnny said, there are lots of wizards and things like that built into MapleTA that make it easy. And really in my experience, what I found is it allows you to be as advanced and make it as difficult as you like it to, or as you want to for yourself. So you can use the wizards that are built in, and they're really helpful. Grading codes all worked out for you, lovely clickable images and things like that. But I deal with lecturers all over the place who go, I love the built-in stuff, but I want to do it my way, because and a lot of lecturers I know are like that. And what MapleTA allows you to do is take full control of the system yourself. So really it can have the sort of, I just want to focus on how it looks, to I just want to focus on how it behaves people. And whoever you are, there's a place for you within MapleTA. And that's really my experience of how we build and author things in MapleTA.
Okay. All right. Thanks. Well, Jonathan, on something related, I'm going to stick with you on this one, is you talked about how lecturers like to do it their own way. And we've been talking about the advantages of automated grading, and I'm sure some teachers and lecturers would like to go full bore on that, and some may sort of hedge their bets a bit and mix things up. So how do teachers, lecturers combine the use of Maple TA with traditional hand grading, for instance? Can you sort of do them both?
Yeah, absolutely. And I actually recommend that. And if you look back through the history of technology, usually a new technology comes along and it really just augments what we're doing. And I think, and especially where we are right now with mathematics, with technology, that is a really great way to do it. I'm a big proponent not of the virtual reality, but of the augmented reality. And so, yeah, so with Maple TA, there's a couple of different question types built in there that really facilitate that. And one of the best ones around that sort of things is like the scanned document question. So a really nice model I like to use for my students is you ask them a hard question with an answer at the end, and they put that answer. And one of the typical questions that people might say is, well, what about the work solution? And so what you can do, there's a couple of methods for doing this. You can either give the student an answer box where they can just type in using the equation editor their work solution. And it's not something the system would necessarily mark, but it's something the lecturer could use to review and maybe award partial marks. Now, again, typing into an editor might be not something a student might want to do. So the other question type they could use is a scanned document question type. And that really allows the student to write down some grading, write down their work solution on a piece of paper, take a photo of it and upload it to the system. So you don't have to walk away from the traditional systems. You can just really use this system to optimize the bits that you do, that they can do well. So computers do some things really well and humans do other things really well. And you should really use those things together to get a great experience. And what we have found by doing that at our university is that if you use Maple TA and humans together, you really reduce your marking load by about 75%. And numbers like $100,000 that you're seeing at Waterloo is exactly the sort of region that we're seeing for savings when you do this. And it gives a wonderful student experience. They get the sort of touch of the human with the speed of the computer. And that's a really nice experience for the students.
Okay. And while we're on the subject of the experience for the students, that Johnny, maybe you can handle this. Can you talk a little bit more about the kind of feedback that Maple TA can provide to students? Can you just, how does that work?
Yeah, sure. So when it comes to feedback, what we talk about is, how students receive feedback on their responses to questions. And in terms of the actual feedback they receive, that can be customized. So it's not just right or wrong. It can be more explanation focused. If it's multiple choice questions, it can also be response specific. So depending on what they select, it can actually be specific feedback itself. As well, you can write in basically whatever you would like for the feedback, incorporating images, video, as well as mathematics. Now, how they receive the feedback is up to you as well. It can be time restricted. It could be pass-fail restricted. It could also be dependent on when the teacher specifically says they receive the feedback itself. And on that same note, when it comes to response-dependent feedback, that is something that we're hoping to expand in the future, where for our free response questions as well, they can get response-specific feedback for those questions as well.
Okay. So, it sounds like you're moving towards that, but let me see if I can clarify that. Does Maple TA do adaptive testing?
We do adaptive testing, but the feedback itself would still be on the question level, which unless you're using multiple choice questions, the feedback would not be dependent on the response. So response-specific feedback for free response questions is coming in the future. Currently, we only have response-specific feedback for multiple choice questions. Adaptive testing, Maple TA does have as well. And the way that works with Maple TA is you can basically control the flow of the assignment. So you can give them easier or harder questions depending on their previous responses. So they, of course, will receive immediate feedback on a per-question basis, but the students themselves don't necessarily know that they're getting harder or easier questions depending on their responses. The teacher designs the tests and the assignments to deliver to students, and they choose which questions to deliver to students based off the percentile that they're currently sitting in.
Okay. All right. Terrific. Well, thank you for clarifying that. I'm afraid we have gone through our entire hour, and that is all the time we have left today. If you did ask a question and we didn't get to it in this time, someone from the MapleSoft team will follow up with you directly to get you some answers. And before we go, I do want to draw your attention to some of the resources that are available. There's a resource box on your console, and also on this final slide here, you have some URLs and addresses if you want to follow up and get more information. So as we wrap up, I want to thank Johnny Zivku and John Watkins again for their excellent presentations, and I would also like to thank MapleSoft for its support. And one final reminder, we will be sending out an email to everyone who attended today when the recording of the webinar is ready. So thank you all for attending, and this concludes today's webcast. Goodbye.